Well, look at that. Ain't that pretty? Wow. That is a lot of gold foil in there. Very, very nice. Well, hello, scrappers. Mike here. Welcome back to my channel. And finally, it's time to start working on this representative sample of pins that I got from Jani in Finland. Quick backstory, if you haven't seen the video, I'll put a link to it in the upper right. Jani, he's in Finland, and he's a scrapper extraordinaire. You should have seen some of the pictures he showed me. Maybe I'll cut a few in here. I'll check with him first to make sure it's okay. He's a scrapper extraordinaire, like I said. He takes apart a lot of old telephone switch equipment, amongst other things. He gets access to a lot of Nokia and Ericsson equipment over there, and he very laboriously scraps it out. And one thing he gets a lot of is these gold-plated pins. That are in the back planes of those switches. Um, he's got 80 kilos of gold-plated pins. And he brought me, when he came to visit, a representative sample. Now, he has 40 kilos total of this type of pins and another 40 kilos of a different type that he didn't give me a sample of. I kind of made a mistake in that earlier video where I said he had 80 kilos of these. He's actually got only 40 kilos of these. So little, so little. But he's got 40 kilos of another type of pins, too. So anyway, he brought me these, and my mission, should I choose to accept it, is to find an efficient method to remove the gold from these and figure out basically how much gold there is here, what the yield is. You know, if he were to process his 40 kilos of pins like this. There's been some talk of me possibly doing it, but if I can come up with a way that he can do it at home, he can do it at home. So, um, multiple methods to do this, okay? We've talked about in previous videos the possibility of using reverse electrolysis. That's one way to go. And based on the comments in that video, a lot of you want to see reverse electrolysis. And it's something I want to get into someday. And my buddy Jim has given me some stuff that'll help in that area. Sorry, there's a little background noise on the farm today. I don't know if that's making it through on the video. So reverse electrolysis, definitely a possibility. I don't think I'm going to put together a whole reverse electrolysis cell just for this little sample of pins. My goal here is to find, just how much gold there is in this, what the expected yield can be. So I think we can do it a little simpler and quicker. Well, simpler anyway, maybe not quicker, than putting together an electrolysis cell. Now, I could just put these in a beaker and treat it with nitric acid and dissolve the base metals and leave behind the gold. That would definitely be a quick way to go. Of course, there's always a danger when you do that there's some tin here. And we'll wind up with that clay-like sludge, metastatic acid, also known as the infamous gray goo, which tends to trap a lot of gold. And you can never be sure you've got all your gold out of it. These pins are not very magnetic. Okay, this is a pretty powerful magnet. It's picking up a few of them, maybe 1 in 3. So that leads me to believe that most of these pins are probably bronze, phosphor bronze. So there's going to be a lot of tin in here. So I might not want to go the nitric acid route with these. That would definitely be quick. But I think maybe we can do better. It's just going to take longer. I think we're going to go the AP solution route, acid peroxide. It's going to take longer, but I'm not in a big hurry. I've got like a dozen other projects I need to work on, so this can just soak an AP solution in the background, and we'll see how long it takes, how well it gets rid of the base metal, and how much gold is in here. So now this is going to take me probably a couple of weeks, but for you it's no time at all because I'll just edit it all together into one video. So I think the first thing I need to do is figure out a weight on how much material I've got here that Johnny gave me. He said a couple 100 grams. We'll weigh it up and see exactly what we got so that in the future, when there's nothing but gold left, we can calculate an exact yield. So let me move the camera and we'll get to weighing. Let's see here what we got. I hope you can read the scale. Yeah, it looks like it's here. It's a bit windy, so. All right, so let's see what we've got here. 28, 47, and a few go flying. 105. Oh, I can't pick it up. Trimmed my nails the other day. Go. And a few more go flying. I guess just one. 200 grams on the money. Johnny, you are incredibly accurate. You said a couple 100 grams? Got a couple 100 grams. Okay. So 200 grams of pins we're starting with. All right, so let me get set up for soaking these, giving them a good long soak in AP solution. I'll show you how I'm going to do that. All righty, I think I've gathered together everything I need. So we've got some muriatic acid here, hydrochloric acid, whatever name you want to use. We've got some hydrogen peroxide here. Now this is 30% hydrogen peroxide. You don't need 30%. You can use the 3% drugstore stuff. In fact, there's very little peroxide left in this bottle, and it's old, so it's probably not 30% anymore. We're going to use it up. So that's the basis of the acid peroxide. Like if you were doing the 3% stuff, you'd do like equal parts of muriatic acid and peroxide. But we're just going to do mostly muriatic acid, a little bit of peroxide, and we'll talk about the reaction here. Let me get these in a tall beaker. Using a tall beaker. Oh, there's some fine powder there. Some of that looks like it's gold too, so we'll get all that fine powder in there. So any beginner level chemistry textbook will tell you that hydrochloric acid will not dissolve copper. It just can't do it. Let me put about 600 milliliters in there. Actually, you know what? There's hardly anything left. Let me just use this whole rest of this gallon. So it's about 700 milliliters. All right. Yeah, any low-level chemistry textbook will tell you hydrochloric acid won't dissolve copper. And as you can see, there's not much of a reaction going on, if any. Okay. What you need is an oxidizing agent to oxidize the copper, and then it can be attacked by the hydrochloric acid. That's where your hydrogen peroxide comes in. But I'll show you another little secret here, okay? We'll probably put all of this in, unless it looks like it's going to bubble over. It might still be pretty potent stuff. Let's see here. Oh, look at the color change. Oh, yeah, and there's some bubbling going on. Oh, yeah. Almost immediately. So you put a little hydrogen peroxide in there, and then suddenly this stuff can attack the copper. So put the rest of this in there because there's not much left. Oh yeah, look at that reaction. Look at that reaction. So that's gonna dissolve the copper, the zinc, the tin, the iron in these pins. But it's gonna take a long, long time because this initial reaction, as you can see, dies down quickly. We're using up the oxygen in the hydrogen peroxide pretty quickly. There is still a lot of bubbling going on. I don't know if that's showing up. Let me give you a little closer look at it here. Yeah, see that bubbling going on? We still got a lot of bubbling going on. That's gonna carry on for the next few hours or even a couple days, but then it's gonna stop once all the oxygen in the hydrogen peroxide is used up. So what do we do to keep this reaction going in the long term? Well, we just got to keep supplying oxygen to it. All right, and to do that, I've got a fish tank bubbler over here. And the fish tank bubble, oh, look at the reaction. Oh my goodness, yeah. We got a heck of a reaction going on here. I probably shouldn't have put so much peroxide in. Hopefully it won't bubble over on me. I think we'll just let this reaction die down, and then I'll show you what I'm going to do to keep it going in the long run. All right, it's been 20 or 30 minutes. The reaction has really died down as the oxygen in the hydrogen peroxide's gotten used up. I don't know if you can tell. It's still bubbling pretty good in there, but not at the level it was. The liquid has turned sort of a deep yellow-green, so I think we're dissolving iron and copper and probably tin out of those pins. Okay, but this reaction is going to stop pretty quickly as the rest of the hydrogen peroxide gets used up in there. And then this will just sit here, and really not much will happen for weeks. I mean, the metal salts that we're getting in solution are quite corrosive, and they will continue degrading the pins over time, but really it's going to take a long time. So to speed this process up, you've got to get more oxygen into the liquid. And you could keep adding hydrogen peroxide to it, but that's an expensive proposition, and you're going to dilute this liquid, which is not helpful. So I got another method I'll show you. So my method to keep the good times rolling here is to use fish tank bubbler. So what I'll do is I've got a piece of glass on the end of the hose here just so it'll sink to the bottom. Get it down on the bottom, and we'll plug it in, and we'll just bubble air through this. I will set this aside somewhere, cover it loosely so that the air can come out, and just let this go. And we got two benefits here. We're getting air into the solution, which contains oxygen, which is going to keep the reaction going strong. And we're also circulating the liquid so that there's no dead spots in there where the pins aren't getting, exposed to the liquid. So this is really going to speed things up. I said speed things up. It's still going to take a week or two probably, at the very least. It is summer in Florida. It's very hot. This reaction is temperature dependent. The hotter it is, the faster it goes. So I'm thinking we'll get this done in a week or two. So I'm just going to set this aside somewhere out of the way, like I said, loosely covered, and we'll check on it after a week or two. So just to keep this project out of my way, not taking up valuable space in my fume hood, not exposed on my workbench where it can get knocked over, I've put it in a bucket. The lid's only on very loosely so that air can escape. The bucket will contain any acidic mist that's coming out of there and prevent it from spreading around. So we'll just leave this in here and check on it in a week or two and see how it's going. All right, it's been 2 weeks. Let's have a look and see what's become of Johnny's pins in here. See if they need to cook a little longer, or if 2 weeks in the hot Florida summer has done the number on them. So I'll pull this out. We'll take a look at it up on the bench. Okay, I pulled it out. It's up on the bench. Still got the bubbler in it. I see some stuff down on the bottom. It's hard to tell just how much the pins have been chewed up by this process. Let me pull the bubbler out. Set it aside. And I'm going to pour off this very dark liquid, which I can't really see through. And we'll see what's left at the bottom. There is a little bit of floating gold. It's a little bit of floating gold. Let me see if I can knock that down with a water spray. Although I might just put this liquid right back on top of it. But yeah, that seems to have knocked almost all of it down. Let's have a quick peek. That is some seriously dark liquid. Well, there's a lot of free gold there, but there's a lot that looks like it might need to be processed a little while longer. I'll give you a close-up look at what I'm seeing in the bottom of this beaker. So here we are. This is what I'm seeing down in the bottom of the beaker there. I would say some of the pins have hardly even been touched, and others, from the piles of gold foils over there, I would say others have been completely digested. So I don't know if it's a matter of thickness of the gold plating preventing the acid from getting in there, or if it's difference in material. It's possible that the more reactive metals are going first and the least reactive metals going later. That's a good theory right there. But either way, these certainly look like they need to cook a little while longer, because there's still a whole lot of pins down there that don't look like much has happened to them. So, yeah. Alright, so I am going to, well, dropped a little bit of gold right there just then, off the end of the air bubbler. Well, I'm going to put this liquid back on it. I may add a shot of HCl to it just to freshen it up. That's got a lot of metal salts dissolved in. You can see some gold floating on the surface there. I'm going to put this on and we'll get her back in the bucket and going again. And we'll see how long this takes. Yeah, so another possibility is that this liquid has just dissolved all the metal that it can dissolve. So we'll put a little bit more HCl in it, maybe up to about 1,200 milliliters. I also used a little bit of water in there to wash all the little bits of gold and stuff out of this other beaker. And I collected the gold that dropped on the bench and put it back in there. So basically we are ready to put this back in. Here we go. And leave it for another week or two and see where we stand after that. Alright, so back in the bucket it goes. I never promised you this was a quick process, but I think we'll get there in the end. Alright, it's back in the bucket. And we'll check on it again in another couple weeks. Alright, it's been about another week and a half. And I had a sneak peek in there yesterday, and I think it's done. I don't really see anything but gold foils in the bottom of that beaker, but I didn't have time to deal with it, so I put it back in there and left it. So today we're going to pull this out, and we're going to have a look. I will pour the liquid off, and we'll see what's left in the bottom of the beaker. I'll pour it off through a filter just to capture any gold that comes over, so we don't lose it. But, yeah, I think this is done. So let's find out. Let me pull it out, and I'll get it up on the bench, and we'll take a look at it. All right. So here it is, got it out of its bucket. There's a little bit of gold floating on the surface, but I'm more interested in what's going on down below. I don't feel a whole lot of solidness amongst the pins down there. Maybe a few, but it really feels pretty soft, like I'm mostly dealing with just gold foils down there. Yeah. Okay, so what I'm going to do is I'm going to dump this liquid off through this filter to capture any of this fine gold. And then we'll have a look at what's down in the bottom and see just how done the pins are. And really, I think, whether they're done or not, I think I'm done with doing them with this process. I think anything that's left we'll go after a little bit more aggressively, just to try and get this process completed here, because this has been about 3.5 weeks now. So let me finish getting this stuff dumped off through this filter, and then I'll give you a look at what's left in the bottom of the beaker. Alright, so let me give you a look at the situation here as I'm filtering this stuff. So we're catching a lot of fine gold inside this funnel, and a lot of, well, crud. Don't know what kind of crud it is. We'll just call it crud for now. But look what's in here. Oh my goodness. Yeah, there's a lot of gold down in there. Yeah. Okay. So I think what I'm going to do is I'm going to just dump all of this in this filter and capture all of this gold and any pins that are down at the bottom that aren't fully digested. I think there might be some down there. Don't maybe look fully digested, but I would say the vast majority of them are. So we'll just process this as if they are all digested. The amount of base metal that's left in here is pretty minimal. So I think we'll get some pretty clean gold out of it, and probably a reliable yield estimate on these 200 grams of pins. So okay, I'm going to let some more of this stuff drip through, get all this in there, and then I'll run some distilled water over it to try and get rid of as much of this base metal stuff as I can, so that we can further process this gold. Yeah, a lot of that base metal is just washing right out of the filter. That's good. Alright, so it's just filtering very slowly now, so this is going to take a while. I'll be back when we are basically done. Well, look at that. Ain't that pretty? Wow. That is a lot of gold foil in there. Very, very nice. Very, very nice. Okay, so I'm going to put this, I'm just going to pull this whole filter out and put it in a beaker. And we'll get it in the fume hood and put some Aqua Regia on it, dissolve this gold. And hopefully there's not a lot of base metal left in there. I mean, it sure doesn't look like it. It actually all looks just like foils. So hopefully that's all we've really got here. Is just foils. I guess if the Aqua Regia turns funky colors, we'll know there's still some base metal there. Okay, so I will let this drip through some more, and then get it in the fume hood and get started on it. Okay, I have pulled that filter out of the funnel. Got all our gold in here, in this beaker. And what I want to do now is make some Aqua Regia and dissolve this gold. So first goes in some muriatic acid. Could a couple hundred milliliters. Oh, actually I put in a little more than I wanted to, but that's okay. There's a lot of paper pulp in there. So we can dissolve that paper pulp in Aqua Regia. Look at all the gold. Wow, look at it. Very cool. Okay. And this time I'm going to pull out my homemade nitric acid. I have a video on how I make nitric acid. You have to buy some equipment. But it's a one-time investment. After that, you can make nitric acid forever. So we're going to put in about 3 milliliters of nitric acid to start with and see if we need more. We'll just see if all this gold goes into solution with that much nitric acid. If not, we can add more. We get the fume hood going. Put a little bit of heat to it, not too much. I don't really want to boil it. And we will see what happens. See if we get any kind of reaction and all that gold starts disappearing. Alright, so we'll just let it cook and check on it from time to time. Well, it sure looks like the gold is starting to go into solution. Oh yeah. The little gold particles are dancing around in there. They start to go into solution and little gas bubbles form on them. Then they'll float to the top. The gas bubbles will pop. They'll sink again. So once that dance starts up, you know that you got stuff going into solution. Alright, that's good. I'm going to go do something else while this is happening, but maybe I'll leave the camera on a time lapse so you can get a good look at what's going on. Alright, I guess it's been close to about 30 minutes here. Looks like most of the gold has dissolved. Not quite all of it. It's only just barely warm, so I'm going to turn it up a little bit over here, and we'll see if we can get the rest of that gold to go into solution without having to add more nitric acid to it, because it looks like we're still getting a reaction. So I don't want to over nitric it if I can avoid it. So we'll just let it cook for a little while longer and see if we get it all in solution. Alright, it's been maybe an hour. Now all that loose gold has dissolved. Alright? I'm stirring it around. I'm looking down on the bottom of the beaker. There's some pins down there that do not look like they have been touched. They still look like they're completely gold coated. There's some down there that do look like they're starting to dissolve, and they're leaving some black muck around them. So some of those pins clearly did not get the memo while they were in AP solution that the base metals were supposed to dissolve. I don't know if you can see it. We got some bubbling going on over there. I'm sure that's base metals interacting with, we got some bubbling going on here. I'm sure that's base metals interacting with the Aqua Regia, because all the gold seems to be gone. So what I'm going to do is I'm going to put another milliliter or two of nitric acid in there just to help promote the dissolution of the rest of the pins. Let me see here. We'll go about 1.5 milliliters, I guess. And just let that continue to, oh yeah, look at the reaction we're getting. Oh yeah. So yeah, the nitric acid, the Aqua Regia, it's attacking those pins down there that did not dissolve in the AP solution. What they are made of, I don't know. Maybe they just have really thick gold plating on them, and the AP solution wasn't getting into them. But the Aqua Regia, well, it seems to be working. So we'll let this cook some more. I was thinking that this was about ready for denoxing and icing, but no, we are not there yet. We still got more stuff to dissolve. So we'll just let it go. Hopefully, it won't take too long. I'm sure the liquid will turn green now from whatever base metals were dissolving in there. Okay, well, just let it cook and see what develops. Well, it's been about another hour, and those pins on the bottom of the beaker are just not going into solution. There's not much that can stand up to Aqua Regia, let me tell you. So that is kind of weird. The liquids turned green, as I was expecting. I'll try to give you a look at what I'm seeing on the bottom of this beaker. Okay, I will try. Not sure it's going to work. Okay, I'm going to try and show you what I'm seeing on the bottom of this beaker. I don't know if it's going to work or not. It's getting a little dark out here. But there are pins on down there that are just not dissolving. Okay. All right, so I guess I got a pretty good video of that. So those pins to me look like either copper or bronze, one or the other. And that black stuff around them, that's probably gold that is cementing out on them. Gold will cement out of Aqua Regia on any kind of base metal that you put in there. So that's probably what's going on. So I think what I'm going to do is I am going to dump this liquid out into another beaker and wash any of that fine material down in there out of this beaker. And we'll get a good close-up look at whatever those pins are after I do that. Yeah, okay. And there's a lot of paper pulp in there, which is kind of complicating the process. I want the pins to stay behind, but they're kind of getting caught up with all the other debris there. I'd like to get all that black powder over here because I'm sure that's probably gold. Yeah. Okay, let me wash those a little bit more and pour the liquid off again, and then we'll take a close-up look at those pins down there. So I don't know if the purple color of this liquid coming off is showing up, but yeah, that's finely divided gold. That's our gold in there. That black powder around those pins, that was our gold. It had come right back out of solution and cemented on those pins. So I need to separate the gold and the pins. Get all this purple stuff over here. Yeah, I'll give it one more rinse. A lot more purple came off that time. You ever heard the phrase royal purple? Yeah. A lot of gold compounds are purple. Alright, so we should have all our gold in here. Let's take a close-up look at these pins, see what they look like. So there's the pins. Yeah, definitely copper or phosphor bronze or something. I am surprised they did not dissolve in the AP. There doesn't appear to be any significant amount of gold still stuck to them. So I think we can discard these. So I would say this is a less than a tenth of the pins that Johnny gave me in that sample did not dissolve. There's obviously something different about these pins than the rest of them. They're very resistant to Aqua Regia and AP solution. Okay, let's see what we could do with this lime green Kool-Aid liquid we got in the fume hood over here. I tell you, nothing's ever easy. So, okay, what do I want to do with this? Well, that purple and black stuff that I poured in here, that's going to be powdered gold. So basically, I need to reinvigorate my Aqua Regia solution here and get it to dissolve that gold, redissolve it. Because it's going to be down here as a solid somewhere. So I'm going to put, since there's a lot of water in there, diluting it, I'm going to put some more uriatic acid in there. Not a lot, just a little. Make sure to keep it well acidified. Diluting it will raise the pH of the liquid. You don't want to raise it too much. And then, of course, back to good old nitric acid. Put maybe a milliliter in. That's probably a lot more than necessary. And we'll just let it sit and cook. And hopefully, any solids on the bottom will go right back into solution and stay there because I pulled the base metal out. And we'll be able to filter this and drop whatever gold it contains in the not too distant future. Although it is getting dark rapidly, it's the end of the day. I may turn off the heat on this and just let it sit overnight and then pick up tomorrow. Okay, it's the next day. I warmed this up again just to make sure that all of the black and purple powder that was in there has gone back into solution. Looked at the bottom of the beaker. I don't see any solids in there other than some paper pulp. Yeah, there's some paper pulp. But there's nothing, there's no metal laying on the bottom of the beaker. No copper, no bronze, no gold. Fortunately, the gold all seems to be in solution. So we're going to denox this. It's probably a little overnoxed. I didn't want to overnox it, but I probably have, trying to make sure everything's back in solution. So I've got my usual saturated solution of sulfamic acid here. Let's see what happens. Yeah, we got a little bit of extra nitrate in there. Yep. Oh yeah. Definitely overnoxed. Quite a bit overnoxed. Well, this is going to take care of that problem. Alright. Let me wash the remaining sulfamic acid out of here into the beaker. And we will call that denox. Alright. Next, as per usual, we're going to put some ice in. I don't want to splatter this stuff all over the place though. There we go. So, when that ice melts, we'll filter that liquid and we'll drop the gold. Alright, so the ice is melted, ready to filter this stuff. I'm just going to gravity filter it through a funnel with some cotton stuffed in the bottom of it. There's not that much liquid here. There's not a lot of solids in it. Most of them are down at the bottom. I'll put that in last. So I think we can just filter it this way. Keep life simple. Yeah. It's a lot greener than I was hoping it would be. That less than 10% of the pins in there that did not dissolve at all in AP solution have contributed some green stuff here. Copper, iron, nickel, who knows? Who knows? But it just seems to be the nature of the business when you're dealing with e-waste. Your Aqua Regia tends to be green. Okay, well, this is going to take a little while, but I think we're getting a reasonably clean filtrate down there. That's why it's taking a while. The cotton's really doing a good job of filtering it. So I'll be back when we're done and we're ready to get this back into fume hood and drop out whatever gold it contains. All right, all nicely filtered. It's an unfortunate color of green, but it's a very clear green. So we've gotten rid of all the particulates anyway. Okay. Let's get some SMB on this stuff and see if we can make some gold here. Be dirty gold by the looks of it, but dirty gold better than no gold. Let's see here. Stump out by Bowden. This is the stuff you need to precipitate gold out of Denox Aqua Regia. It contains sodium metabisulfite. Other stump removers don't contain SMD. So shop wisely. So this is so green. Are we actually going to see the color change? Yes, we are. There it goes. Okay, I was afraid it would not be obvious, but there goes the color change. All right. So we are getting the gold drop. Excellent. Just let this sit and do its thing. And after it settles out, see how much gold we got. Yeah, there's a little bit floating on the surface. A little dendritic gold. That's always cool. Okay. Keep the sulfur dioxide gas in, and we will just wait and see what develops. Well, here we go. The gold has all settled out on the bottom of the beaker. Looks like we got a decent amount there. Okay, so I'm going to do my usual thing. I'm going to siphon off the liquid off of the gold, and probably put the gold in a smaller beaker for some cleanups. I'll give you a look at the gold after I get the liquid off of it. Well, here's the gold. Now they've got that nasty green liquid off of it. It's always hard to tell whether you've got a lot or only a little when it's on the bottom of the beaker. I guess we'll find out when we get to weighing it. Alright, before we weigh it though, I want to clean it up some. So I am going to transfer this to a smaller beaker, put some distilled water on it, and give it a couple of boils in distilled water to get rid of the remains of that green stuff and any other metal salts that are mixed in with the liquid there. So let me get started on that. Okay, I've got about a centimeter of distilled water over the top of the gold, and we're going to bring it up to a boil. Start cleaning up the gold, getting rid of anything that's left over in there. So I'm going to do this 3 times. I'm going to bring it up to a boil. I'm going to pour the liquid off through a filter just to catch any fine gold that stays in the liquid. I'm not expecting there to be much. This looks like pretty good gold, actually. And whatever I catch in the filter won't be enough for me to weigh with my equipment, so I don't think it's really going to affect whatever yield I calculate. But anyway, I'm going to boil it 3 times, then dry it out, and then we'll give it away and see what we got. All right, there's our gold after 3 cleanup boils. Just gonna dry it out in here, and then we'll weigh it and see what we've got. All right, the gold is all dried out. Looks like we've got plenty here that we can weigh. I think we did pretty good with those 200 grams of pins. Yeah, there's a fair amount of gold here. Okay, let me get my scale set up here. Right, let's see what we've got. Oh, the beaker's still hot. I didn't let it cool off enough. I was eager to see just how much gold we got here. Looks like about 1.2 grams. All right, 1.2 grams from the 200 grams of pins we started with. So let me get my calculator going here. So we had 1.2 grams divided by 200 grams equals, so about 0.6% gold by weight on that sample of 200 grams of pins you sent me, Johnny. Now that sample was a mix. There were obviously 2 or 3 different types of pins there. I'd suspect at least 3 types from the reactions I was seeing. So your mileage may vary slightly, but still that's not bad. 1.2 grams out of 200 grams of pins, that is not too bad at all. I'd take that. So that's kind of what you could expect. I did the AP method, as you saw. That's basically the cheapest, most hands-off method of doing this. It's going to leave behind some copper pins that are going to give you issues if you do it this way, or if I do it this way. But that will process the bulk of the pins. And it's super cheap. It just takes time. Time versus money. So, sometimes you want to do things the least expensive and simplest way you can to maximize your profit margin, rather than using more expensive chemicals and doing it quicker. And I think if we had used nitric acid on these things, we'd have probably had some metastatic acid issues, which can get in the way of recovering the gold. So 6 of one, half a dozen of the other. But we got there in the end. So I'm going to add this 1.2 grams to my gold repository. Now, I call this dirty gold because it's only been precipitated from solution once. Once I get an ounce or a little over, I generally re-refine this gold again. And we're getting close, getting heavy. I will re-refine it a couple more times to make it really pure, then I'll melt it down and make a bar. That's the way I generally do things. So stay tuned for those future episodes where I'm refining and melting down the gold. And I'm pretty happy with this 0.12 gram yield. And if you guys are happy with this video, give it a like, give it a thumbs up, and subscribe to see those future videos. And I'll see you in the next one. Thanks a lot for watching this one. Bye.